In this presentation, we will learn how to create a complete circular singly linked list. So let's get started. Let's create a separate function for creating a complete circular singly linked list. And here is how function looks like. This is a create list function where we are passing just this pointer tail. Currently, you should assume that tail is holding null. Okay, and we are calling this function from the main function. I'll show the complete code after this presentation, but currently this tail pointer has null. And you can see over here I have declared three variables I, n and data. I'll tell you why I have declared these three variables in a moment. After this, I'm calling this printf function to print this message, that is enter the number of nodes of the linked list. That means I want to ask the user to enter the number of nodes you want to add in the linked list. I will store that number within this n variable. That is why I am calling this scanf function. After this, you can see that I am using this procedure. If n is equal to 0, then return tail. That means if user has entered 0, that means user doesn't want to add anything, okay? Then simply return tail back to the main function. We know that tail is currently holding null because there is no node in the list, right? Returning tail means we are returning null only. This means that there is no node in the list. If this is not the case, then this message will get printed, that is enter the element 1. That means I'm asking the user to enter the element 1, and then I'll store that element within this data variable. And obviously for this purpose I have to call this scanf function. And please remember that there must be an ampersand before data as well as n. You should never forget to put ampersand in front of these two variables while calling scanf function. Okay? After this scanf function, I'm calling this function that is add to empty, and to this function I'm just passing data. We already know what this function does, right? This function is used to add the first node of the linked list, and the address of that node will get returned back to the tail, that is this particular pointer. After this, you can see that I'm using this procedure. Basically, this procedure will help us in adding the new node at the end of the list, and let me tell you why. Here you can see I am using this for loop, and within this for loop the first thing is I is equal to 1. Now you might be asking why I is not equal to 0. Because I've already asked the user to enter the element 1. Now I want to ask the user to enter the element 2 and enter the element 3, enter the element 4 and so on according to the value of n. For this purpose, this I must be initialized to 1 and I must be less than n in this case, because I want to run this loop until I becomes n. After this, if this is satisfied, then we will get inside this loop. Here you can see I'm calling this printf function to print this message, enter the element %d and colon. Now this %d will get replaced by I plus 1 at runtime. Here you can see currently if I is equal to 1, then this will get replaced by 2. That means I'm asking the user to enter the element 2. Now you can understand what is going on, right? After this, you can see I'm calling scanf function to store that element within this data variable. And then finally, I'm calling this add at end function, because I want to add the subsequent nodes at the end of the list. That's why I'm calling add at end function. There must be some add at end function which will add the data at the end of the list. To this add at end function, we have to pass tail as well as data. This function is used to add the rest of the elements at the end of the list. And this is how this whole procedure works. In the similar way, when I becomes 2, then actually I'm asking the user to enter the element 3 and so on. Finally, we'll return tail back to the main function. And that's it. Now let me just show the complete code in code blocks. You can see over here, this is the complete code available. Struct node is declared. We have add to empty function, add at end function. Then we have this create list function also, right? This is similar to what we have seen already. After this, we have this print function, and you can see some changes in this print function as well. Here I have added this case also. That is, if tail is equal to null, then print no node in the list. Okay. Else, we will evaluate this piece of code which we have already seen. And then we have this main function. And in this main function, you can see I have declared this tail pointer, and to this tail pointer, I'm passing null. And here I'm also calling create list function. And to this create list function, I'm passing tail. And then you can see over here in this create list function, I'm returning tail, which will get returned over here. Then finally, I'm calling this print function to print all the elements of the linked list. Now let me just execute this code. It is asking us to enter the number of nodes of the linked list. Let's say I entered 4. Let's say the first element is 90, then we have 98, 99, and let's say 100. You can see over here, these are the elements printed, 90, 98, 99, 100. So our code is working fine, right? Now let me just execute this code once again. And this time I will enter 0 over here. You can see that this message will get printed, that is no node in the list. When 0 is written, no node in the list will get printed on the screen, which means that code is working fine, right? Let me just execute this code once again. This time, let's say I will enter 1. Enter the element 1, let's say it is 90. So 90 will get printed on the screen. So code is working fine, right? Okay friends, this is it for now. Thank you for watching this presentation.